So, folks, today we'll be looking into probabilistic grammar fuzzing. What does that mean? It's actually a very simple concept that goes a long way. Let us take a look again into our regular fuzzing with grammars. Here we go again, and here we have all the ingredients that you already have seen. We are importing the concept of a grammar, we're having our advanced grammar fuzzer, we are having a grammar, and now I can actually create a grammar fuzzer with an instance. So let's do this right away. Expression grammar, if I recall it right. Here we go. And once we have that one, we can invoke g.fuzz and happily create individual instances of that grammar. So that's very simple. But what if I, as a programmer, maybe as an attacker, want to exercise more control over what's being produced? Notably, if there are specific parts of my grammar which I'd like to test more, for instance, because I think that there may be hidden opportunities in there to actually find mistakes, for instance, because some piece of code has changed or because some piece of code is overly critical. For this, we have the concept of probabilistic grammar fuzzing, and this is a very simple concept. The idea is to assign individual probabilities to individual elements in order to have them produced with a higher or lower probability than the others. Have a look at this at our digit rule here, for instance. Here we have 10 different digits, and all of them are produced with exactly the same probability. This is because in our grammar fuzzer we do have this random choice function, which simply picks every single element out of that list with the same probability. And now I can go and add an extra expansion to the thing. I can go and add a special function which we have for specifically such extensions. And the name of this function is opts. I need to import this earlier on from grammars up here. And this is used as follows. I'm using a tuple here. So first comes the actual element, and then come the options I want to set for this particular element, which can, for instance, be probability is equal to 0.9. Well, that's a very high probability. Okay, this is a way of extending grammars, and I can put in arbitrary options in here, which will then be picked up by the respective fuzzer. And we do have a probabilistic grammar fuzzer which picks up these probabilities. What this now means is that the element that comes with this particular probability will now be produced at a probability of 90%. And the remaining 10% will be distributed across all the others. So each individual one will be produced with a probability of something like 1.1% in here. So once I've done that and I've added this in here, let me see whether everything is fine. I think I need a closing parenthesis here. Here we go. Note that this does not affect the original grammar fuzzer at all. It simply ignores all the options that are set in here because these options are only for advanced grammar fuzzers. Now what we do is we have a new grammar fuzzer, which is the probabilistic grammar fuzzer, and this is a grammar fuzzer which actually picks up these probability elements. So let's make this P, and I'm writing probabilistic grammar fuzzer, and just as the other one, I instantiated with the grammar. So here we go. Wonderful. Now what happens if I invoke a fuzzer in here? Now the probabilistic grammar fuzzer actually picks up the probability, and if I now create a string in here, you're going to see exactly what was expected. You see that the majority of digits, actually over time it's 90%, the large majority of all digits are now 9s. And I can also go the other way around. I can also say I want no 9s at all. Then I set the probability to 0 down here. I instantiate it. Yeah, do you see any 9? No, you don't see any 9 in here. Great, let's do this again. No 9, no 9, no 9 again. And I can also compose my, and I can also go and compose my arithmetic term only out of, say, additions or mostly additions and well, nines. So I say options is probability equals 0.9. So here we go. So this is a tuple, and again, I think everything is all right. So now we have plenty of additions, and I want plenty of additions with nines in them. So let's see. This is still our original grammar fuzzy. It's not affected by these things at all. But if I do this now, yep, we get plenty of pluses in here. So this still favors lots and lots of additions. Keep in mind though that the probabilistic grammar fuzzer is not going to simply apply this at all times, because otherwise we would have a big explosion in the string, because it would always favor an expansion. The original rules that we have set up for grammar fuzzer in particular, that after a specific length we stop expanding and we go for the shortest possible expansion, still apply. And this shortest possible expansion then does not take into account the probabilities. It simply tries to find whatever is needed to quickly close the expansion. And this allows you to exercise control over what is being produced. One particular nice application of this is that you can also learn these probabilities and from existing inputs by parsing them, and we have a section on this in the chapter. And this then allows you to produce inputs that are either similar to the ones that you already know, or remarkably dissimilar to the ones that you know. And this is of course helpful if you already have a couple of seed inputs and you want to produce inputs that are different from these in order to obtain more coverage or to trigger more bugs, because bugs tend to be in places that are less rarely executed, less frequently tested. And for this, you can actually learn these probabilities from existing input. The key to all this is a simple function in our probabilistic grammar fuzzer. Let me just switch over to that one. Here we go, expanding my probability. And in here, there is a function called choose node expansion. Sorry, here we go. And this is the key to our probabilistic grammar fuzzer. So what we have here is we go through, this is a function which is already present in the base class, the grammar fuzzer, and by default it simply chooses an arbitrary element out of that list. And what this function now does, the extended function, is it puts together a list of weights. It computes the weight for each of the alternatives, and it puts these together, and then it invokes the function random choices by passing over these as weights, and the random choices function from Python is doing the rest, namely picking up one expansion alternative according to these weights. And this is already pretty much all there is in terms of probabilistic grammar fuzzing. I wish you plenty of fun reading the chapter and looking through the implementation and trying out probabilistic fuzzing by yourself. Enjoy!